Hello everyone, I'm back in recording tutorials again, and to get myself back into the swing of things and to keep things simple, I'm going to start out with a tutorial to just show you how to create some concentric rings, scaling up your copies linearly, which isn't as straightforward as you would think. So without further ado, let's dive in. Okay, so in the scene right now I've got an example geometry, and then I also have like an empty geometry just to create the setup in again. And I'll hide this one and we can start from scratch rebuilding that. I'll dive inside, and the first thing I'm going to do is create a circle. And I'll hit space G to center my viewport on the circle, and I'll give it some more subdivisions. I'll drop down a polypath. And I'm using the polypath just to convert it to a line, and I'll make sure the ends are closed. You don't need, if you're going to sweep it, you don't need to do that, but I figured it's easier to view for the tutorial. Now I'll create a copy and transform. Let's type in copy and get copy and transform. Drop that down, set my display flag to that, and I'll create 20 copies. So now if you scale this up with uniform scaling, you're not getting that linear scaling effect. You're getting, each time it scales, the distance between the lines gets bigger, which isn't what we want to create that that look, because this is being scaled relatively. So each time it's scaling, it's accumulating based on the previous scaling that's happened. And that's not what we want. We want linear scaling. Now, one of your first thoughts might be, what if we drop down a for loop instead and try and scale it that way? Get a transform. Transform. And I'm creating 10 copies with the for loop if I set it to merge iterations. And I scale that up, and we end up with the same problem. So how do we fix this? I'll get rid of the loop. I'll go back to the copy, and I'll set the scale back to 1. So a copy isn't doing anything. It's just taking our one circle, and you can see one primitive, and turning it into 20 circles. Now, what I want to do on this is turn on this copy num attribute and handle my scaling afterwards. So I'll get a wrangle and plug in the wrangle, and I'll create a float attribute called scale. And I'll say scale is equal to prim 0, and I'll get that value copy num, or attribute, and I'll get that at the prim num. And because each of these points only has one primitive associated with it, you can do this. You can just get the prim num as an attribute, and it's going to get the correct value from the primitive. So it's a nice little trick. You don't have to promote values if it's only a single primitive that is associated with a point. And then I'll take the position and multiply that by that scale. And you can immediately see we're getting something a bit more like we would expect. And the reason for that now is we're scaling it linearly based on this copy num attribute in the geometry spreadsheet. Now we want to add some controls to this, and there's a couple of things to watch out for. So if I just display the points, you'll see we're now getting a ring that's at 0, and that's got a bunch of points stacked on top of each other. Because the first copy num attribute is 0, it's scaling the position by 0, so it's shrinking our first ring to 0, which we don't want. So we've got two options to go with from there. We can either add 1 to this, Now what we should get is our first one in the center, and we don't have that 0 point anymore, and we can put this whole section in brackets and multiply that by a constant. So I'll create a parameter, say channel f brackets, and let's call this scale, and I'll create that parameter, and let's scale this up. Now you can see what's happening. Everything is scaling linearly like we want, but it's also shrinking the whole thing. So our first ring isn't respecting the initial value. Now maybe we want that, maybe we're not too bothered by that. Let's show you if you go above 1, it still works, but the whole thing is getting bigger and smaller. The other way we can do that is if I just copy this wrangle, and instead of adding the +1 there, I can change this expression and say 1 plus primitive num, and then I put all of this in brackets. So it's primitive number times the scaling. Now our initial ring stays constant and everything else scales linearly. So that just depends on what you're trying to create with your linearly scaled rings. And after that, I'll drop down a sweep node. This is the easy part. Plug in a sweep. And we can just scale this up until they touch. Now we've got concentric rings with a hole in the middle. Maybe I don't want that. I can switch it to this one. And then you'd have to find the right values. So I think if I scale this by 1 and I scale this to 1.5 because it's a radius, you get something like this. Let's see what it looks like for this one. 0.5 and 1. Yeah, you get that. And if you want to close a hole, you'd need to scale this up bigger and make everything thicker. These are all going to be relative to whatever your initial circle is. Okay, so that's working. I'll turn on wireframe. Probably want a bit more detail on that as well. I'll just bump this up. We can zoom out a bit, and now we have these really nice concentric rings. And if you want to color it, you can use that same copy num attribute to color the points. So the sweep will bring across that primitive attribute, so we still have copy num. So if I middle click, we can visualize that. There's our copy num, and you can use that to drive colors. I'll just do something quick and lazy to show that, and I'll get an attribute color, attribute adjust color, plug that in. Oh, I think I need to promote that value, so I'll get attribute promote, and the attribute promote also for primitive to points. And then you got a couple of options. I'll say remap attribute. It won't pick up the attribute on the drop down by default because it's an integer. So that's copy num. You can see it's kind of working, scaling between 0 and 1. So let's bump that up to 0 and 10. You can see it's giving us that result, and then you can cycle it so it keeps going. And there we go. Now we've got concentric colors. I'm calling this one quick and lazy for the colors because you can see it's not completely evaluating correctly. Like, you'd have to do this a bit more nicely because it's missing red. So this isn't properly scaling in a normalized way. Should be fairly easy to fix, but that's not what this tutorial is about. and I'll leave this one there. I hope you found this useful. Thank you for watching. It's good to be back and recording again. Please like and subscribe if you like it, and if you like to see more simple procedural modeling tips or any more simple Houdini tips, leave it in the comments so I know you like it. And yeah, thank you for watching. Goodbye.